What makes freezing an exothermic reaction? Imagine holding a glass of water on a cold day. As the water turns into ice, heat seems to vanish from your hand. That's because freezing actually releases heat into the environment. It might sound strange, but it's a key part of how phase changes work in thermodynamics. When a liquid freezes, the molecules slow down and settle into a more ordered, solid structure. This process releases energy, called the latent heat of fusion, into the surroundings. Instead of absorbing heat, the system gives off heat, making freezing an exothermic reaction. During freezing, molecules lose thermal energy, which is the energy that makes them move faster. As they slow down, they form stronger bonds with each other, creating a solid. This bonding releases energy because the molecules are moving to a lower energy state. The heat released during this process warms the environment slightly, which is why freezing water can slow the cooling of the air around it. In thermodynamic terms, the system's internal energy decreases because the molecules are now in a more stable, lower energy state. The energy difference has to go somewhere, and it flows out as heat. This is why when water freezes at 0 degrees Celsius, it releases heat to the surroundings. The heat flows out because the molecules are transitioning from a high-energy liquid to a low-energy solid. This principle isn't just limited to water. It applies to gases and other liquids changing into solids. When gases cool down enough to become solids, they also releases heat. The phase change from liquid to solid always involves energy leaving the system, which makes it an exothermic process. Understanding why freezing releases heat helps explain many natural phenomena. For example, in weather patterns, the formation of ice in clouds releases heat, affecting temperature and storm development. In refrigeration, cooling systems relying on this principle to remove heat from inside a fridge. And in materials science, controlling phase changes allows us to develop stronger, more durable materials. So, in simple terms, freezing is an exothermic reaction because molecules slow down, bonds form, and energy is released into the environment. This process is fundamental to how many natural and man-made systems operate, showing us the fascinating way energy moves during phase changes.